Okay, folks, my name is Matt Thomas, and thank you for tuning in to the USGS Landslide Hazards Program Seminar Series. For folks that are new to this meeting, you have the ability to submit questions via the chat window or to use the raise your hand feature in combination with your microphone and video camera. We typically wait till the end of the presentation to take questions, but feel free to enter them in the chat window as the talk progresses, and then we can address those questions at the end. In the meantime, please just do your best to make sure your microphone is muted when you're not intending to speak. I just also like to note that today Helen is our kind of second speaker in part of a new mini-series where we hope to hear from one state survey each month. These talks are intended to provide an overview of the program, including expertise, focus areas, and product types, and introduce some of the more pressing landslide-related problems that state faces. If you'd like to have your state landslide work spotlighted as part of this mini-series, please shoot me a message via Teams or email, and we can coordinate a date. Jamie, I'll go ahead and turn it over to you.
Okay, thanks, Matt. Helen and I are former colleagues at the Pennsylvania Geological Survey, and it's really my pleasure to introduce her today. Makes me nostalgic looking at her photo on her title slide. Helen was raised on Cape Cod, which sparked an early interest in geology, particularly coastal geology. She received her bachelor's from Tufts University and a master's from SUNY Binghamton, and following her master's, worked for a short time for the National Park Service at the Cape Cod National Seashore. Helen joined the Environmental Geology Division of the Pennsylvania Survey in 1980. At that time, she was the only non-oil and gas person working at the survey's Pittsburgh office, where she worked on Lake Erie coastal issues, general Western PA geology inquiries, and landslide hazards. In 1989, Helen moved to the main survey office, which is located in Harrisburg, where she's worked on a number of different things, including siting critical facilities, LiDAR acquisition, GIS, local government outreach. She's always remained the main point of contact for landslides for the entire survey, whether in Pittsburgh or in Harrisburg. She's currently working to wrap up some landslide inventory work, and after more than 40 years at the survey is contemplating retirement, but no official plans yet. So Helen, the floor is yours.
Thanks, Jamie. I'm going to switch over to presenter mode, and there we go. Have you got the big screen? Yeah.
Not yet.
There. How about now?
You're good to go.
Okay. As Jamie said, I've been kicking around Pennsylvania for a little over 40 years now, and for most of that time, I have been the part-time landslide program. We heard from the nice folks at the Washington Survey, and I'm envious of their 7 full-time equivalents. We've got 1 part-time equivalent, but maybe we make up for it by longevity. We'll see. Anyhow, most of you are probably somewhat familiar with Pennsylvania landslides from the Pittsburgh viewpoint, but most of you, since I see that this crew is largely a Western group, may not know a lot about Pennsylvania or the survey. So I'm going to tell you a little bit first, and then we can look at some landslides. So, like many state geologic surveys, we are an arm of government. We are not tied to a university. We've been around since 1836. Our legislative justification is pretty broad. We are charged to go out and study the geology and make it available to the public. There is no specific mandate for us to do geologic hazards work, but it certainly is allowed under our umbrella. At the moment, we have a full staff of 31 positions. As you can see from the red lines, we've got a number of folks who have recently retired. We're generally a crew of senior citizens. About half the staff could retire tomorrow without notice, but we hope they're going to hang in a little longer. We're in the process of filling all but one of these positions right now, so we should be back to full complement pretty soon. COVID was a little rough. There were hiring freezes, but those have been lifted, and we're now moving forward. Survey has 3 divisions of geologic mapping, which I'm in the groundwater and environmental geology section. We have conventional field mappers, a couple of groundwater folks, my counterpart who does karsty stuff, and a superficial geology mapper. The Economic Resources Division is heavily oil and gas and mostly in Pittsburgh, but we have a small group in Harrisburg who run the scanning electron microscope and the X-ray stuff and look at economic minerals and minerals in general. And we have a GIS and geoinformation section that does our publications, GIS work. We have an actual full-time librarian for our paper and some electronic resources. And we have a core and cuttings library with a full-time custodian who is a geologist and the usual administrative staff. We used to have in-house IT people, but they've been lifted and put as an umbrella over other state agencies. So we do have IT support, but they're not our employees. So on to what Pennsylvania looks like. Unlike your Western mountains, we don't go that high, but we do have some relief. Many of you have seen this in your intro geology classes. We have the folded Appalachian classic linear mountains where the sandstone ridges hold up the sky and the karst and shale valleys in between. The Allegheny front here is the break between the folded mountains and the Appalachian plateaus where the rocks are basically flat lying. Well, there are some general wrinkles. For landslide purposes, we're going to ignore everything south of the first ridge here at Blue Mountain because the Mesozoic basin would have landslides if it had any topography in the red shales, and the Piedmont similarly doesn't have enough topography to have significant landslide issues. So we'll be looking at the other parts of the state primarily. The colors in this, the white areas are above 2,000 feet. The green is below 500. The yellows and browns are in between. Highest point in Pennsylvania, Mount Davis, is down here in the southwest, about here. Pittsburgh is here. You'll be seeing more and hearing about it where the Allegheny and the Monongahela rivers come and make the Ohio, which goes out there. Philadelphia, for sports fans who care about that, is over here. Oops, my laser pointer is not moving very well. There you go. Physiographic provinces, I alluded to those, but they have official boundaries. We'll talk about some of that. Most of that showed up in the other, but just to show we do worry about these a little bit. The USGS folks will recognize the classic colors of geologic map formations by geologic age. We have the Great Valley here with Cambrian and Ordovician carbonates and shales. We hit the Silurian with the Tuscarora sandstone at the first Kittatinny or Blue Mountain. And we move up through Silurian, Devonian, Mississippian, Pennsylvanian, and to a little bit of Permian in the southwest, the plateau. In Pennsylvania, because everything is Paleozoic except our small Mesozoic basin, these colors get boring. So our geologic map looks like this, but for those used to the classic colors, it's a little disconcerting. This does add detail, and you can see that there are some gentle folds here in the eastern edges of the plateau coming off of the compression from the really wrinkly mountains. Things that we'll be looking at in southwestern Pennsylvania, the yellow formations, Conemaugh, are some of the bad actors, as well as the continuing shales and things. These are deltaic and terrestrial sediments for the most part, with occasional marine incursions, lots and lots of clay, some fluvial sandstones interbedded. There's cyclothems, so there's lots of small-scale variety within the formations, which makes it a little tricky to pick out where the landslides are most likely to be. But the bad actors are commonly some paleosol units in the deltaic shales that have some interestingly weathered clays that are the roots of some of the landslide problems in Pittsburgh. In other parts of the state, the Devonian and adjacent Devonian Mississippian units, which are also deltaic. This is the Catskill Delta coming off of mountains to the east and shedding sediments off to the west in the upper Devonian. It also has both some volcanic ashes and some paleosols. Again, it's very difficult to map single units within it, so we don't have a good handle on those specifically. And it has occurred to me that maybe mapping landslides would be a way to map where some of those paleosols are. But that's a bigger task than I'm likely to accomplish. Structurally, things in the ridge and valley are very steeply dipping. There's anthracite coal mining in some of these basins to the east, and rock standing on end around here. And we get over, there's a concentration of activity, as you'll see, along the Allegheny front, which is structurally understandable when you realize that that's where the flat stuff is butting up against the really folded stuff. There's some interesting things going on at depth that the oil and gas folks can tell us about. But it means that some of these rocks are more intensely fractured than necessarily expected from just their surface exposure. So there's your basic geology lesson. And then in the Pleistocene, we did get glaciated partly. However, all of Pennsylvania was subject to periglacial intense weathering. We've got gelifluction and solifluction lobes all over lots of the mountains, which we're able to see now with LiDAR, but actual glacial deposits are limited. The other important thing that happened in the Pleistocene is that the river drainage in western Pennsylvania formerly went into what's now the Great Lakes. When the first ice came down in the early Pleistocene, it dammed that drainage, backed up a big lake, overflowed into what's now the Ohio River, and sent all that water down to the Mississippi. If you remember your fluvial geomorphology, you'll realize that the Mississippi drains into the Gulf of Mexico at sea level, and Lake Erie is at about 500 feet. And therefore, those rivers have been adjusting to a new base level for the last couple of million years, and they're not done yet. So that's the root of many of the steep slopes in western Pennsylvania, is that the rivers had to downcut an extra couple of 100 feet, and the middle and upper tributaries are still doing so. So my talented retired colleague John Harper drew this cartoon as the cover of a guidebook for the Field Conference of Pennsylvania Geologists about 2 weeks after I started working at the survey. And it nicely summarizes what's going on with Pittsburgh geology. We've got interbedded sandstones undercut by weathering shales, the weak red bed paleosol claystones, valley deepening, and as the valleys deepened, vertical stress relief fractures tended to form along those valley sides, which led to some big bedrock slides, which can get reactivated. Periglacial and postglacial weathering of clay-rich rocks has produced some very thick colluvial soils on lower slopes. There are the usual bedrock discontinuities of fractures and bedding planes. We put some good-sized rivers on it, and then we built a city. And then we mined the coal. The coal actually has very little to do with landslides, but the general public would love that it would, because there's insurance for coal mine subsidence and there is not insurance for landslides, as most of you probably are aware. So, Pennsylvania surveys history with landslides. In the 1960s, the oil and gas folks in the Pittsburgh office were asked to assist the highway department and some municipalities with some local landslides relating specifically to some major highway development around Pittsburgh. They assisted with general geologic information, X-ray identification of clays, and so forth. But we didn't have anything approaching a formal program. In the 1970s, everybody got environmentally aware. Pennsylvania created a Department of Environmental Resources, and the survey was moved into it. We created an environmental geology division, and one person was sent to Pittsburgh. Also at that point, a consortium of the US Geologic Survey, the Pennsylvania Survey, the Appalachian Regional Commission, and a bunch of other agencies developed a project called the Pittsburgh Regional Environmental Geologic Study. I think there were some other similar ones in other major cities around the country at the same time. I believe Cincinnati had one and probably some Western ones. But this was a major effort to look at environmental geology in the 6 counties around Pittsburgh. They produced a new 1 to 125,000 geologic map, mapped coal mines, mapped floods, produced slope maps, and started making landslide maps. The 2 major players in the landslide maps were Jack Pomeroy and Bill Davies, both now deceased, but they were good folks, did a lot of good work. They used aerial photos and some field checking, produced 7.5-minute quad scale maps for Allegheny County, showing old landslides, new landslides, features they thought were related to landslides, and coal mining features and fields. There's a USGS circular, if you could look up, that details some of that work and talks about it. But those maps were well received, although as we'll see later, not as well used as they might have been. And so the quad scale landslide mapping program was expanded and included most of Western Pennsylvania in the pink and red areas shown here, and also extended into other states all down the Appalachians. They produced in Pennsylvania, I think it's about 380 quad maps. As a cooperating agency, the Pennsylvania Survey is a repository for those maps, and we got stacks of Mylar reproducible copies of them. The originals were hand-colored on paper topo maps. We got photocopy Mylar reproducibles. And if you want to look at some of those, you can still find them through the USGS Open File Reports program, but we have scanned PDFs available on our website as well. Again, they were done with aerial photo interpretation, and unlike the Allegheny County group, which had some very nice low elevation photos flown, this used whatever photos already existed, so they vary considerably, but it's a good effort, and the maps have been useful. They're not perfect, but they're pretty darn good, and especially in the area around Pittsburgh and Southwest, remarkably still useful. As part of this larger project, they also chose several specific areas for more detailed studies. There are a number of USGS miscellaneous field studies and miscellaneous investigations reports that came out of it. They looked at some areas around the glacial border up in Warren. They looked at some things in East Grady, up here in Armstrong County. They looked at some sites in Washington County that were in coal mining areas. And they looked at a quad down here in Greene County. So those maps are available. And they did some now seemingly simplistic looks at mapping by slope or mapping over dip slopes, looking at things, but it was a good start. The best summary of some of that work is Jack Pomeroy's USGS professional paper, number 1229, and I'll send you a link to that later in the chat. Here's what some of these look like now laid over LiDAR data. This is a section in suburban Pittsburgh. The LiDAR laid over an orthophoto is fairly straightforward. You can see nice flat-lying bedrock, flat upland surfaces, flat valley bottom, and steep everywhere in between. The red stuff is the information from the USGS maps. The solid red is what they perceived was an active landslide when they were mapping. These cross-hatched areas are older landslides. And the stippled area that will be hard for you to see is soil and rock susceptible to landslides, which was basically laid out by looking at where the old landslides occurred. Now, here in Allegheny County, you've got, say, clay-rich soils, lots of colluvium on the slopes. The maximum relief is 400 feet. So, you know, we don't have big mountains, but we do have steep slopes, and we have a city built on them. Here's another example near Pittsburgh, actually in the city of Pittsburgh. They turned old city street in this valley bottom into what's now Interstate 279 and cut through the toes of quite a lot of old and landslide.
So this is suburban Pittsburgh. You can see, I can't move my mouse, but you can see flat-lying sedimentary rocks, flat upland surfaces, flat creek bottom, and the red overprint is the information from the USGS landslide maps. So let's go to the next one. This is a similar, different way of graphically showing it. This is in the city of Pittsburgh, where they took an old road through the bottom of the East Street Valley and turned it into an interstate. This is Interstate 279 on the north side of Pittsburgh. And the dark reds are active landslides. The pink were old landslides. The green was soil and rock susceptible to landslides. Folks used to looking at LiDAR can probably pick out many of the landslides on the slope, but it's also interesting that all the new highway construction has obliterated some of them. That got kind of complicated and expensive as they were building the highway and had to move rather a lot of material. Next slide. This is in far southwest Pennsylvania, and the guys making the USGS maps didn't quite believe the intensity of landslides. They thought they were picking up on air photos. So Jack Pomeroy spent 3 weeks in one quad mapping in detail and published a freestanding miscellaneous investigations report. And the red overprint is the information from that overlaid on a LiDAR slope map for a small part. So you're further, you're up into the Permian and uppermost Pennsylvanian rocks, thinner units, but you still have alternating thin sandstones, shales, clay stones, thin coals, underclays, freshwater limestones, and they weather produce, it's hard to argue, very thick soils when you can see all those bedrock layers in the LiDAR, but the soils that are there are pretty mobile. So next slide. So anyhow, after the USGS folks decided they were done with mapping in Pennsylvania, the Pennsylvania survey took on the project to extend that to the next 1 by 2 degree sheet east, the Williamsport report. Pete Wilshusen from the Harrisburg office and I got assigned to look at that, and we spent a couple of years doing air photos and field checking, and he did mostly the east and I did mostly the west, but we collaborated. And for editorial reasons, this didn't get published for a long time, but we have this report, which is not bad. There are a lot of things we misidentified now that we can see LiDAR, but we probably over-identified some things that are likely paraglacial features, but there are a lot of solid landslides that we did identify. We did not attempt to do a full inventory of all 128 quads because that would have not been possible in the time span we were given. So we did a statistical sample of the quads, made sure we covered all the typical types of bedrock and superficial geology, generalized the information on landslide occurrences to attempt a susceptibility map. But we did publish reduced scale 7.5-minute quads in the report showing all of the slides we identified. So this is, like all of our publications, now available as a PDF and can be downloaded from the web. We don't have any more paper copies. We don't do that anymore. It got too expensive to shelf them. So, oh, come on. Next slide is the 1 to 250,000 scale map that came out of that report. You can't see the individual black dots for the landslides, but the darkest blue is what we considered high, which not high compared to some other parts of Pennsylvania, but high for this area. Susceptibility, which was largely the north draining river valleys, which are full of glacial lake clays and other glacial sediments. Some of the very dendritic valleys in the western part, which are very steep, dissection into the Devonian sandstones and shales, mostly shales in the high plateaus, unglaciated section of the Appalachian plateaus, and a couple of high mountain ridges in the lower central area, Bald Eagle Mountain, which is sort of the last big sandstone mountain before you hit the Allegheny front, and over in the southeast, the tail end of that sort of what we call the anthracite banana in the eastern section. So I don't know how much use this map has ever gotten and been used, but it's out there, and this is not a heavily populated area. A lot of forest land, a lot of farmland. There's not a lot of development yet, but there is some, and we're hopeful that this may be a useful product. So we have an education series publication, illustrated, next slide, sorry, illustrated over on the left here, and the little map is the centerfold for it, is just a real thumbnail based on physiographic provinces of a sort of high, medium, low. I would be hard pressed to defend some of these, and I would put a higher zone down in the far southwest, but the editors wouldn't let me have another color. So this is out there as, again, a sense of where there is some landslide activity in Pennsylvania. Next slide. Into the 21st century, we are now moved into a department called Conservation and Natural Resources. They split up the old Department of Environmental Resources, and the regulatory folks are now in a different department. So we get a different set of requests from the public for support, but we do get some requests for assistance to municipalities and individuals, hand-holding of individual homeowners with landslide. We can't fix anything, we're not engineers, but we can counsel them on the types of people they need to hire and so forth. I've been collecting media reports, and in this internet age, that's gotten a lot easier to do. I can get newspaper or digital TV reports of lots of landslide incidents. Again, the Pittsburgh market is the big area, but I pick up some others as well. So I've been collecting and saving those. As a part of a data preservation effort, I started looking at the old case files from the 1960s to present and some academic and published reports. And I've been compiling all of that into a GIS database. I now have approximately 600 Allegheny County landslides, all of which have a good location within a couple of thousand feet at most, sometimes very, very good locations, and some sort of a date. It may be the occurrence date, it may be the report date, but there's some date that links to them. Some of them have polygons, some of them have quite extensive data on damages and causes, some have merely an entry that someone phoned us, they have a landslide, and we put a dot on the map. But there's some information there, and that is anticipated we're working on plans as to exactly how to release that. We have IT issues, and but I'm anticipating that that will be available to go into the USGS combined inventory map and released as a freestanding database in some form. I can't tell you exactly how or when, but it's going to happen before I retire. And in the 21st century, we got LiDAR, which you all will appreciate. So next slide. I worked on this, as did Jamie, but in 2006 to 2008, we acquired statewide LiDAR, now lower res than we'd like. It's QL3, but it's all the same resolution, all the same tiling scheme, and available free. It has changed the way we do geologic mapping, as you all can appreciate. We were among the first states to have statewide LiDAR. That's no longer as big a deal as it used to be. However, we are moving to having a second pass of QL2 LiDAR. The black areas here are what's available right now to download, and we anticipate that the rest of the state will be filled in before the end of this calendar year. The stuff has been collected and is in processing. So we should have 2 sets of LiDAR, and I'm actually looking forward to seeing what happens when we start comparing them and seeing what happened in the intervening 10-ish years. So that is the summary of any kind of a landslide program that the Pennsylvania survey has. As I alluded earlier, it's sort of me half-time or thereabouts, and obviously the LiDAR is a huge issue. I worked on it in the early years. Now it's a consortium. USGS is managing the project. And we're doing other things with it as well. But that is what we've got for anything that can qualify as a landslide program. But now I'll show you some bells and whistles and a few things that we've learned about. After the OSO Washington event, we thought we might get questions about whether anything similar could happen anywhere in Pennsylvania. And we had statewide LiDAR, so I took a look. I took known large landslides, and I'll show you a couple of them in a bit, and I did a visual scan of a statewide slope layer projected at 1 to 24,000 and looked for large slides that I could see on a LiDAR slope map. I found around 100, 120 that seemed large, but when I looked for a way to screen them, I pulled a number out of the air and screened off an area of 1 million square feet and found we had about 38. About half were in bedrock and half were in glacial deposits in northeastern, north central Pennsylvania, and none of them were in western Pennsylvania, which is what we think of as landslide country. So here is the map I used in a GSA poster presentation. The red boxes were call-outs to specific information about some individual landslides. And we'll look at a couple of those, and then I'll take you on a tour of some other landslides. I think the limiting factor to keeping us from having large landslides is that our hills aren't high enough. We have what we call mountains. Most of you from the West would laugh at them as mountains, but they certainly were a barrier to historic transportation, and they're pretty and they're lovely. They do have trees on top of them for the most part, but they are a significant topographic feature in Pennsylvania, and as you'll see, they have some pretty good landslides. Next slide. This is, I believe, the largest, is the largest known landslide in Pennsylvania. It's on a bedrock dip slopes, dipping southeast in Devonian and Mississippian sandstones with some shale interbeds. Along this flank of the mountain on the north branch of the Susquehanna River, just southwest of Scranton and Wilkes-Barre, there are a whole row of these. There are perhaps a dozen, all smaller than this. Most of them didn't run out onto the floodplain, at least not yet. On the left, you can see an orthophoto, and you can see why perhaps we didn't pick it up on air photos as a landslide in the Williamsport mapping. That was not an area we were statistically assigned to do, but we did pull in some other things we knew about. But on LiDAR, it shows up rather dramatically. It's about, it's almost 4,000 feet across, and according to Dwayne Braun and a couple of other colleagues who published in a GSA special paper, they believe this whole series of slides are post-glacial, but probably haven't moved significantly in more than 4,000 years. You can read their rationale for that. I'll provide the reference later, but they do still show signs of looking kind of fresh and active, but there's nothing creeping out at the toe, no discernible movement, and believe me, the folks in the county emergency management folks know about them and are paying attention. So, however, I strongly suspect that at some point this may have blocked the whole river, and if it should move again, it would block the river again, and Scranton and Wilkes-Barre could get a little damp. This is one of the other slides in that series along the mountain. You can see the size and nature of the mountain and a cross-section from Dwayne's work. Simple block slide on a bedding plane surface on a mudstone layer with some glacial deposits on the toe that got distorted a bit, but they're not the primary moving force in the landslide. We assume the other slides along the mountain front are pretty similar. Next slide. Are we on to Torbert now?
The picture, Helen, the picture I see is a cross section of mudstones, sandstones, glacial deposits, and it's a cross section of the slide mass.
Okay, I had just been talking about that. I'm sorry, I forgot to tell you to advance. So now go to the next one.
Okay, now we're on Torbert.
Okay, this is another one of the very large slides that we picked up. Pete and I did find this in the Williamsport report. Pete had been called out to talk to a homeowner in 1978. And if you look in the little black and white map in the upper left, there's a little debris flow outlined, and that little debris flow knocked the porch off a house, but didn't do much other damage right at the very toe. And he knew about it, and so it was within the Williamsport area, so we went to look at it. And we hiked up the debris flow drainage, and when we got to the top, we realized that there was a whole lot more going on up there than we had been aware. Now, the graben across the top of this is shown on the Pennsylvania State Geologic map as a fault. A fellow in 1960 picked it up on the air photos and mapped it that way, but Pete and I looked pretty hard on both sides and couldn't find any evidence of it coming around the other side of the hill as a fault. So we think it's just this big rock slump. You can see the in the gully of the debris flow that it's scoured down to rock, but I now would not call that bedrock. I think it's probably moved as part of the landslide. And over on the right-hand side, you can see what it looks like on LiDAR. The colors are just an elevation gradient. And I drew a couple of cross sections and profiles across it. Clearly was a whole lot more than we could discern through conventional aerial photo interpretation, and even hiking up to the top and walking around. We spent 2 or 3 days on this looking at it, but that was about all we had time to do as part of the project. But Again, it doesn't seem to be moving actively, although there's some stuff drooling off the south edge there in the low bottom of the photo that looks fairly fresh. I don't know that the big block is likely to move, but if it does, it's going to kind of mess up the floodplain of Pine Creek, and there are some houses down there and a fairly well-traveled road. This is a forested area, but lots of hunters and fishers and vacationers go up there, and there aren't a lot of roads in this country. They all tend to follow the stream valleys, and if you block one, it can be a pretty long detour. So next slide. We do not have the kinds of big debris flows that the North Carolina folks get in their big mountains, where you get a debris flow coming down the mountain, or that you've got in Colorado recently blocking up I-70, but we do have some debris flows. This is, I believe, the oldest reported debris flow in North America. I've asked a lot of people and nobody's seemed to come up with one later. There are some older landslide reports up in the St. Lawrence Valley, but in 1779, David Rittenhouse, who was a Philadelphian of some note, heard about this thing and rode his horse over to look at it, and was so confounded by what could have caused this great gash down the mountainside that he wrote to his friend Benjamin Franklin, who at the time was in Paris, asking whether or not there could be an electrical explanation for why sandstone bedrock at the very top of the mountain was scoured out in a bowl and all the stuff flowed down the hill. Backing up and explaining, the left photo orthophotography shows that you can't see much through the modern forest. My husband and I read about this in a local historical society journal. Somebody was editing Franklin's papers and came across this letter. So we went out to see if we could find it. I looked at all the conventional air photos. This was before we had LiDAR, and found one set of photos that had a shadow that showed what might have been an appropriate groove, and we had some interesting adventures getting to it and finding it, but we convinced ourselves and other folks that it really was this particular event. And then later when we got LiDAR, it was a good excuse to play with different lighting angles on a hillshade. You can't show a groove on the mountain when the mountain runs northeast southwest with a northwest lighted hillshade, but this is a southwest sun angle, low angle hillshade, and it shows up the groove down the mountain beautifully. I can't show you with the cursor, but if you follow the red arrow down the straight line into the little stream valley, and then along this debris flow moved into the stream valley and down a total of about 4 miles to the larger stream in the valley. And the red dot on the geologic map is the location of that. It's on Blue Mountain, the first Tuscarora sandstone mountain on the north edge of the Great Valley. We do still get some of these more recently. Next slide. Sorry, do you have a LiDAR image on it? I think I was doctoring up the slides, and I may not, but this was...
Hi, Ellen. Yeah, you're on Cowans Gap State Park debris flow, yep. And it's got a hillshade, yep.
Yep, okay. Well, that hillshade was supposed to fly in later, but it won't do it on your version. So anyhow, the left photo shows a view down the channel, and the right photo, partly blocked, shows some sandstone blocks piled up against some trees, but you can see at least the bark scoured off the trees. And you can see the LiDAR image. Cowans Gap is a state park west of Harrisburg in the Folded Mountains. Again, this is Tuscarora sandstone bedrock, nearly vertical. The tip of the red arrow is up the ridge top. In this case, the sun angle on the hillshade is from the northeast to show the debris flow. But it's remarkably similar to the Carlisle Deluge in good nature and scale. debris levees, scoured out bowl, not quite at the top of the mountain, but close to it, straight down chute. In this case, it jumped across a state park road and through a rural disposal dump where folks had dumped their trash, but spread said trash out through the campground down below, and eventually some sediment got into the state park lake. So we don't get a lot of these actively, but we have a list, and there are some, and we obviously do get them. But it's not a problem because the size of our mountains is such that, and we don't have the valley network that folks further south have in the Blue Ridge, where you get the Hurricane Camille and so forth, things that the North Carolina survey has to worry so much about. So there certainly is development pushing into these mountains. Used to be just hunting camps and state parks. Now more people are moving out there. It'll be interesting to see with COVID whether people who want to work from home are going to move out rurally. But it's not a huge problem for personal safety, but we do have some of them. So next slide. Up in northeast Pennsylvania and north central, as I alluded in the Williamsport map, we have valleys full of glacial lake sediments. Here, probably me, excavating a sample up on the hill slope below a scarp, and on the left, a 6-inch ruler showing the barbed clays. And if you go to the next slide, again, this one was supposed to be one that would sail in, but if you have the Mansfield quadrangle.
I'm looking at, Helen, I see we're on Glacial Lake clay slumps, and it says Tioga County, Pennsylvania.
Yep. Do you have an image, or if you just got the words?
Oh, we have the image as well.
Okay, so you've got a LiDAR image with some red stuff over it. Okay, these are some of these mapped, and the red overprint is the mapping we did for the Williamsport project. So you can see some of these are pretty good size, but they're all along the stream banks and burning up. The next slide will be on a road that is in the west central part of this LiDAR image, as well as a view down the stream valley. So next slide, Glacial Lake clay slumps, view of the stream valley with the whole right-hand side of that stream bank is slumping, being actively removed by stream erosion, and the road has a headscarp in it. And these things move pretty continuously, but pretty slowly. And at least in the 1980s, the highway department's attitude was it was not dangerous enough to need to do anything more substantial. And their approach was that they would just keep repaving it every couple of years. Clearly about time to do that again in this photo, but the uphill side of this road probably has approximately normal thickness of roadbed, and on the downstream side, you got a whole lot of built up layers of asphalt. So this is, again, a rural area. This is a state highway and gets some traffic, but there are largely agricultural land, and the cows aren't going to get too upset, and these things are not moving fast. But there are lots of them scattered around in north central Pennsylvania, and in a little bit I'll touch on a reason that I'm fairly worried about them. So next slide. This was the image behind the title slide, just to show that we do get some other things. This was a recent November 2020 bedrock slide. Believe this is, I haven't been to visit it, but I believe it's a bedding plane failure in some of the Silurian shales. That's the, you're looking west along US Route 11 near Danville, if you know Pennsylvania, and that's the north branch of the Susquehanna, not too far above where it joins the west branch and turns south. Took about a week for the highway to be reopened on that. and it was a long detour to get around. Again, this is a place where the roads pretty much run in the valleys, and it can be a long way around. Next slide. I would be remiss if I don't touch on the Lake Erie shoreline. I know Matt has been up there not too long ago. We don't generally consider this under our landslide program, but I've spent some time in my early years of the survey working up there, and we really should. The lake is constantly eroding the high bluffs. The bluffs through most of the 47 miles of Pennsylvania's Lake Erie shoreline are steep, 60 to 150 feet high. Bedrock glacial sediment contact is pretty close to lake level. It fluctuates up and down a bit. The tills are, again, an irregular surface. And then on top of the tills are lacustrine deposits from previous high stands of the proglacial lake. So you get these gravels and fine sands and silty sand mixes. You can see that the cliff swallows really like that silty sand for nests. And for the same reasons, this stuff is susceptible to piping. So you get, there are other landslide processes that go on along the bluffs, but this was a nice photo to show that, yes, that is a substantial area of things falling, but again, the lake continues to remove it, and there are building setbacks required, but it's a special area, but a small part of the bigger Pennsylvania problem. So next slide. That's the quickie tour of most of the slides, but I'll whiz through here. We're running out of time, but I want to talk about the impacts of landslides in Pennsylvania. Deaths and injury are blessedly rare, almost entirely related to highways, rock falls when somebody drives into it, or a construction accident, something falls while a road cut is being widened or something. But we have lots of damage to highways, lots of transportation delays and detours, which can be pretty expensive. And the societal impacts, if a road is closed for any substantial time, of emergency access, long detours, school bus access, and then repair costs obviously are a factor there too. We have, especially in urban areas, which largely means Pittsburgh and suburbans, damage to homes and other buildings and loss of use. Other infrastructure you don't always think about, but water lines, sewer lines, gas lines, and electric lines. Two of the fatalities I know of in Pennsylvania were when a landslide in a residential setting ruptured a gas line, the basement filled up with gas, and the pilot light popped it off. So that's not real common, but is a significant verdict. And then pipelines and railroads importantly carry freight and increasingly fuels, both locally produced. Pennsylvania is a coal and an oil and gas producing state. And we're also seeing interstate transport of things like Bakken crude oil from North Dakota moving through Pennsylvania on rail lines. So I worry about both of those in landslide areas. Next slide. And again, this is supposed to be a group of sailing in, and it won't probably in your version. If it does, you can click through. On the left is a photograph of the Buckeye Pipeline landslide. The orange stripe up at the top is a orange snow fence indicating the location of a former haul road for a little coal mine that was around the corner. The coal was mined out and they abandoned the mine and stopped maintaining the road, which was just a dirt road. It happens that this haul road was built across a major petroleum pipeline, and it was built up and probably built correctly and so forth. But when the maintenance stopped, the drains under the road got plugged up, and in a rainstorm in 1990, we got the slide on the right. I don't know if that's clicking through for you, Matt, but there you got people standing on the top of a headscarp. And
we got it.
The landslide was a fairly insignificant debris flow until it ruptured a 10-inch, quarter-inch diameter pipe full of transmixed petroleum being sent to a mixing station in Pittsburgh. And this was a small valley filled up. I don't know if you've got the mashed pipe in your picture too. Anyhow, 75,000 gallons of transmix got dumped into this little tributary valley to the Allegheny River, well upstream of Pittsburgh, but a number of municipalities got their water from the river and had to shut down, and the National Guard had to deliver water, and they closed areas for, gas fumes, and the pipeline company was not happy because they couldn't rebuild, and we wouldn't let them run the pipe around the head of the valley through a number of other old landslides, and they were shut down for quite a long time and lost a lot of economic growth. This used to be the most expensive single landslide I knew of in Pennsylvania, just because of the damage and so forth. Next slide. You've heard of the Marcellus natural gas play or the Utica play, and Jamie knows more than she wants to about this perhaps. In 2004, they started drilling new gas wells for this wonderful new prospect where they could kick over and drill horizontally and hydrofrack through some fairly thin black shales and produce lots of natural gas. Well, here's the showing the highly promising areas of this. And you might notice that these are somewhere close to some of my highly susceptible landslide areas. So we've got major oil and gas drilling activity, gas wells, big platforms. The big platforms are all up on top of the hill, and they're solid. They're not going anywhere. But they need roads, and they need pipelines. And I am considerably worried about the effects of those in landslide-prone areas. And in fact, we've been getting lots of phone calls for landslide maps from pipeline companies and so forth. But I do know we've had several cases I've heard of in West Virginia, but at least one case in Pennsylvania in the last couple of years. A small landslide ruptured a gas collecting pipeline or gas distribution, I'm not sure which pipeline. The resulting explosion destroyed a house. Fortunately, there were no people at home, but a couple of horses and dogs were killed. The people would have been had they been home. So this one is something that gives me great concern about drilling activity and pipeline and road construction into previously pretty undeveloped rural areas. And I worry about this one a fair bit. So anyhow, Pittsburgh backyard landslides, at least partly human cause. Here's an example from the 1970s. These happen anywhere you have landslide country. They're no shock to any of you folks. But we've had them in the 1970s. We had another one in the 1990s. This one, again, should have some pictures sailing in, but I don't know that it will in your version. The two houses at the top were ultimately taken down. The 8-unit apartment building at the bottom was destroyed. The apartment building at the left was evacuated, but later rehabilitated. But the scarp was right at the foundation of this upper house in the middle, and trees from the landslide poked through the siding of the apartment complex. And it's a fairly small landslide, but when you've got houses in the middle, it becomes an issue. Next slide. Again, I don't know that you can do a series of click-ins on this or not, but this is a similar backyard landslide in a new and upscale housing development south of Pittsburgh in Washington County. These were $300,000 homes in a development that probably had 100 houses and 2 roads in, and the toe of this landslide blocked one of the roads into the housing development, and the shoulder of the landslide was beginning to encroach on the other road into the housing development. And ultimately, they had to move the slide mast to open the lower road, which meant that they didn't dare do this until the 3 houses at the top were taken down and the houses falling. So 3 people lost, 3-year-old $300,000 houses. Now, to Californians, that's not a high real estate value, but in Pittsburgh, those are pretty nice houses. So substantial damage effect there. Next slide. And this is the Killbuck landslide. Again, if you're seeing the summary view, it's a little hard to trace the scarp, but this was a former state hospital grounds, eventually sold off for development, was going to have a Walmart built on it. They were regrading the slope in the Pittsburgh red beds, colluvium, and at 2 in the morning, it cut loose and blocked 4 lanes of a state highway that was a major commuter route to Pittsburgh. This is about 5 miles west of downtown Pittsburgh. And it blocked 2 lanes of the Norfolk Southern Railroad's main line between Chicago and the East Coast. So, again, subsidiary damages. It's been sort of stabilized now, but nothing will ever be built there. And as far as I know, Walmart is finding a hard time getting anybody to take it off their hands. There are lots of good stories to go with it, but we're running out of time. Next slide. So what good is our technical knowledge? We keep having landslides. The state did, after the Walmart slide, try to create a program and wrote some legislation. It never got out of committee. We've heard this story before. Legal regulatory situation in Pennsylvania is that there is no specific authority, and the Pennsylvania emergency management folks are beginning to pay much more attention to landslides, partly after some events in 2018 that you'll hear about next week. But again, mostly these are small individual backyard slides. They don't rise to the level of a disaster, which floods do. And so it hasn't been on the emergency management radar. But all land use planning and regulation in Pennsylvania is at the municipal level. And there are 2,500 individual municipalities, and some of them are very small and don't have much capacity. Counties don't have much power here. And next slide, hope for the future. Some municipalities do have good landslide zoning regulations. We're hoping more will develop them. Allegheny County has a new landslide task force and a nice web portal with information. We're hoping that will be productive. Online maps seem to reach the public better than the old paper maps. They're all used to looking at Google Earth and using their GPSs. And we're looking forward to the new federal legislation and what that will bring. And I think that's it.